Now let's prove that if you take a number, a positive integer, n, and you cube it and you subtract it, then you get a number that's divisible by 3 every time, right? So n cubed minus n is going to be always divisible by 3. So let's take a look. So for n equal to 1, we're saying that 1 cubed minus 1 is equal to 0, and so 0 is divisible by 3. For n equal to 2, we're saying that 2 cubed is 8, minus 2 is equal to 6, and 6 is divisible by 3, right? It's 2 times 3. Let's look at another one, n equal to 3, so 3 cubed, it's 3 times 3, 9, times 3, 27, minus 3 is going to be 24. So 24 will be divisible by 3. It's actually 8 times 3, right? Okay, so let's check, and I mean, and what this is saying is that if you continue to do this, it's going to be always true. But of course, we need to go beyond just checking a finite amount of cases, and here's where induction can help us. So let's start by the base step, which we already did essentially over there. So we need to show that it's true for n equal to 1. So for n equal to 1, n cubed minus n is equal to 1 cubed minus 1 equal to 0, which is divisible by 3, right? So very good. So the base step holds. Now we need to do the inductive step. So let's do the inductive step. So what is the inductive step? So once again, the idea is that we want to show that if it's true for one number, it's going to be true for the next one. So assume that it's true for n equal to k. And so what do we mean by that? We mean that k cubed minus k is divisible by 3. Okay, so let's assume that. And now we need to show for n equal to k plus 1. So then, for n equal to k plus 1, so what do we have in this case? So let's look at our statement here. So let's look at our statement here. So n cubed minus n. So then for n equal to k plus 1, we're looking at k plus 1 to the power of 3 minus k plus 1. Okay, we need to show that this is divisible by 3. Well, let's start by opening this up. So that cubed, you can open it into k cubed plus 3k squared plus 3k plus 1, and then minus k minus 1. Okay, and the idea now is, are we able to show that this whole thing is sort of like 3 times something? And we are essentially, the tool we have, or the extra thing we have, is our inductive hypothesis that we know that k cubed minus k is divisible by 3. And you can see that there's a k cubed minus k appearing here. And so let's try to isolate that part out. So k cubed minus k is here, and we know that that part is divisible by 3. So let's look at the rest that we get. So the rest of it, we're going to get 3k squared plus 3k, and then plus 1 minus 1 is 0. So that means that what we have is a number that's divisible by 3 plus 3 times some number plus 3 times another number, right? And so k squared is an integer, k is an integer, so we get 3 numbers that are divisible by 3, so we can write all of this as 3 times some number, right? So here, the inductive k cubed minus k is divisible by 3. And clearly, 3k squared plus k is also. Thus, the sum is divisible by 3. Okay, so that means that by induction, so since, let's recap, since we showed that this statement is true, it's always divisible by 3 for n equal to 1, and if n is equal to k, then it's true for the next one, then by induction, this will be true. So n cubed minus n is divisible by 3 for all positive integers